Hey, Dennis, how's it going?
Not too good, Mike. Now, I'm having trouble figuring out these wiring diagrams. In fact, last week, I had this dream that I got stuck in a wiring diagram. I mean, there I was, trapped, and I couldn't figure out which way to go next.
Well, hey, have you seen the new neon wiring diagrams? They're different.
Yeah, right.
Well, then you obviously haven't seen them. Here, as a result of technician response to a recent survey, they've been changed. So they're much easier to use than the wiring diagrams in previous manuals. As a matter of fact, why don't you give me a hand with this month's Master Tech? We're going to cover some of the changes you'll see in Section 8W, and then do a sample problem using only the new wiring diagrams for diagnosis. What do you think?
I guess it can't hurt.
Great. Let's get started on new wiring diagram organization. When you open up your new Neon Service Manual to Section 8W, one of the first and most important changes you'll notice is that the diagrams are now divided into sections. For example, Section 8W10 contains all fuse and fuse block information. Section 8W32 contains the wiring diagrams for the anti-lock brake system. And if you wanted to find a diagram related to interior lighting, you need to check out Section 8W44.
So each system on the vehicle has its own numbered section containing information relating to that particular system?
Exactly. And the section numbers should remain the same from year to year and across car lines. Of course, vehicles with other options may have more sections. For example, Section 8W39, Vehicle Theft Alarm. But once you get familiar with the section numbers, you'll be able to open any domestic manual and turn right to the information you need. The Section 8W Table of Contents lists all of the systems and their section numbers. There's also a complete list in this month's reference book. So, do you notice any other changes in the organization of this section?
Well, there's more than wiring diagrams. There are circuit descriptions, too.
Right. These circuit description pages give you a brief description of the system from an electrical standpoint. This will help you understand the system before beginning diagnosis, or clarify any information which may not be clear from the wiring diagrams. For example, let's say you were going to diagnose a problem with one of the speakers, and you wanted to know which wire was the feed to the speaker and which was the return.
Well, that one's easy. All I have to do is look at the wiring diagram. The lower number is the feed, and the higher number is the return. Or is that the other way around?
Well, if you're not sure which is which, a quick look at the circuit description would tell you the feed and return wires for each of the four speakers. Another new feature of the wiring diagram section, also found on the circuit description pages, is called Helpful Information. Under this heading, you'll find some simple diagnostic checks and additional tips that will aid in diagnosis. And directly following the helpful information, you'll find a diagram index for the section. This index lists the components pertaining to the system and the pages where they're found. So, instead of searching through a multi-page index of the entire vehicle wiring section, like in previous manuals, to find the right fog lamp, you can simply look it up in the System Index, and then turn directly to page 8W50-6.
Don't you mean sheet 56?
I was wondering if you'd catch that. Actually, the sheet numbers have been eliminated. The new wiring diagrams are indexed by their page number found at the top of each page. And while we're on the subject of page numbering, you may have noticed that currently the circuit description pages are identified by an A preceding the page number. For example, the circuit description pages for the front lighting section are 8W50, A1, A2, and A3. And the actual wiring diagrams are found on pages 8W50, 1, 2, 3, and so on. However, in the next edition of the service manual, the A's will be eliminated, and the pages will be numbered consecutively throughout each section.
Well, now I know how to find a specific diagram in Section 8W. But what if I wanted to find a connector on the vehicle? Now, are there still illustrations to help me locate the connectors?
Sure. Actually, there are several sections, such as the connector location and splice location sections, that deserve some special attention, since you may need to refer to these a lot. All right, let's take a look at these, beginning with section 8W01, the general information section. Now, since you've used these wiring diagrams in the past, I'm sure this section looks pretty familiar to you.
Oh yeah. I mean, this has wire code identification and the symbol identification chart, as well as wiring repair and connector and terminal replacement information.
Right. But in the Neon manual, the general information section now contains information on components that are sensitive to electrostatic discharge and troubleshooting tools. In addition, several basic troubleshooting tests have been added, and the connector and terminal replacement procedures now include special tool usage. For example, instead of simply pulling on the wires to remove them from the connector, by using the proper special tool from kit number 6680, you can now push the wires from their terminals, making connector and terminal repair and replacement much easier. The next two sections, 8W10 and 8W11, contain all fuse and fuse block and power distribution center circuit information. In 8W15, you'll find the ground distribution information.
Oh, wait a minute, don't you mean ground location?
No, actually that comes later. This section identifies each of the grounds, any splices that connect to the grounds, and any components that use the grounds.
So let's say that I was looking at this ABS diagram, and I wanted to find out what other components use ground G101. Now all I have to do is turn to page 8W15-1, and I have the information I need.
Now you've got it.
Well, what about splices? I mean, is there a place I can find out all the circuits that are part of a certain splice?
Sure. Section 8W70 shows you each splice in its entirety. And both the ground distribution and splice information sections have their own index, which lists grounds and splices in numerical order, so you can quickly find the one you're looking for. Another section you may need to refer to quite frequently is section 8W80, the connector pin-out section. Here you'll find all of the connectors, along with pin information for each of the connectors. Also, in an attempt to make this section easier to use, the cavities of the male connectors have been numbered in the same clockwise direction, except when the cavity numbers are molded onto the connector. This numbering is similar to what you'll find in the diagnostic procedures manuals. Here again, you'll find an index listing each connector and the page where it can be found. And finally, if you need to find the physical location of connectors, grounds, or splices, you'll need to check out sections 8W90 and 8W95. Section 8W90 provides connector and ground locations, and 8W95 gives you splice locations.
And I imagine these sections also have indexes to make connector and splice identification easier.
They sure do. However, these indexes are a little different. In sections 8W90 and 95, the connector and splice number are not indexed by page number, but by figure. Also included in the index is a brief written description of the location, and in the case of connectors, the color is given. In the next section, we're going to review wire code and symbol identification and discuss improvements to the diagrams themselves. But before we move on, try this review question. When trying to identify all components which use a particular ground, you should refer to A, section 8W15, B, section 8W70, or C, section 8W90. The answer is A, section 8W15. This is the ground distribution section, which identifies the grounds and the splices and components that use each ground. So, Dennis, what do you think so far?
Well, it sure seems easier to find what I'm looking for, but I guess I won't really know until I check out the diagrams themselves.
Good point. So, let's take a look, beginning with wire code identification. First, you should be aware that each wire shown on the diagrams is coded to help you identify it. This can best be explained using an example. So, Dennis, why don't you tackle this one, using a wire from one of the diagrams?
Okay, now let's use this one. Now, each wire code can be broken down into 4 parts. Now, the first letter in the code identifies the main circuit. In this case, L tells you that this is the circuit for exterior lighting. The first number identifies the part of the main circuit.
Right. Now, this numbering system varies from circuit to circuit, but generally, the lower the number, the closer the circuit is to the feed. The higher the number, the closer it is to the ground side of the circuit.
And the next number indicates the gauge of the wire, in this case 20. And the last letters indicate the color of the wire. Now here we would see a white wire with a tan tracer. A brief explanation of these wire codes, as well as the main circuit and color charts, can be found in section 8W01 of the service manual, or in this month's reference book.
In addition to wire identification codes, wiring diagrams also use a number of symbols.
Of course, you don't have to remember all of these, since they're listed in your service manual, but you should become familiar with some of the more common ones.
Well, now that we've reviewed the wire codes and symbols, I guess it's time to take a look at some of the changes. If you've looked at the new diagrams, you've probably noticed that they're much easier to read. This is partly due to the fact that information not relating to the system is no longer included on the diagrams. This means that connector pinouts and splices are no longer shown in their entirety on the diagram page, but have been moved to the sections we discussed earlier. In addition, only the parts of a component relating to the system are shown. For example, only the 40 amp maxi fuse in the power distribution center and the 10 amp fuse, or fuse number 4 in the fuse block, are shown on this diagram, as they are the only fuses which pertain to this system. A dashed line around both the PDC and the fuse block reminds you that these components are not shown in their entirety on the diagram page. And a dashed line between two pin numbers, like this, indicates that both of these pins belong to the same connector. When looking at these diagrams, you should also be aware that all switches, components, and modules on the diagrams are shown in the at-rest position, with the doors closed and the key removed from the ignition. In most cases, power flow is from top to bottom, and arrows are used to indicate the direction of power flow. Callouts indicating connector, splice, and ground numbers are underlined and generally found to the right of the item. In addition, type size between circuits and connectors, components, and splices has been changed to enhance readability. Section references have been added to the diagrams to aid in locating information. And finally, connector, splice, and ground numbering has been revised to indicate which vehicle harness the connector, splice, or ground is part of. Those connectors, splices, or grounds in the 100 range indicate the engine harnesses. Those in the 200 range are part of the instrument panel harness. The 300 range indicates connectors, splices, or grounds which are part of the body harness. And those in the 400 range indicate jumper harnesses. Remember, these numbers indicate the harness that the connector, splice, or ground is part of, not necessarily the location.
So you mean that a connector in the 100 range might be found in the instrument panel, but only if it's part of the engine harness? Well, like the data link connector. Now we all know that it's found to the left of the steering column, but its connector number is C104. Now that must mean that it's part of the engine harness.
I couldn't have said it better myself. So now that we've gone over the changes to Section 8W, why don't we see for ourselves if it's easier to use by trying a sample problem? But before we dive into the sample problem, let's try this review question. Which of the following is not true about the updated wiring diagrams? A. Connector and splice information has been moved to separate sections to ease readability. B. Connector and splice numbering has been improved to indicate which harness the item is found on. Or C. All switches, components, and modules are shown in the on position with the key in the ignition. The answer is C. Remember, on all wiring diagrams, all switches, components, and modules are shown in the at-rest position with the doors closed and the key removed from the ignition. You know, Dennis, I've been thinking. You're getting pretty good with these new wiring diagrams, but now it's time for a real test. It's time for you to try an electrical diagnosis on your own. Now, a customer brought this neon in complaining that the power door locks are not working, and that's all I know. So, here's a service manual, there's the car. Good luck.
Well, I guess we start at the beginning. Of course, our first step is to verify the customer's complaint. So, checking the door locks, we find that the driver and passenger door locks are inoperable in both the lock and unlock positions. Now, our next step might be to hook up the DRB3. But by looking at the wiring diagram, well, we can see that power door locks are not controlled by one of the vehicle control modules. So, the DRB3 diagnostics tests, well, they won't help in this case. So let's turn our attention to analyzing the wiring diagram so we get a better idea of what might cause this problem. Well, looking at the circuit, we can see that the power door lock circuit gets battery voltage from fuse number 3 in the fuse block, which is supplied voltage from the 40 amp headlamp fuse in the PDC. So if either of these fuses are blown, well, both locks would be inoperable. And that's exactly what the helpful information section says. Check the 40 amp fuse in the PDC and check fuse 3 in the fuse block. But before we start checking anything, let's look at the rest of the circuit to find out what else might be causing a problem. Well, the most likely areas for a problem seem to be the switches or the wiring. Now, as you can see, if the circuit is operating properly, battery voltage is supplied to both the switches on circuit F35. If lock is pressed on the left door lock switch, battery voltage travels down the P36 circuit to the bus bar in the right door lock switch. Now from here, voltage is supplied to all 4 door lock motors on the P33 circuit. Ground is provided on the P34 circuit back to the right door lock switch. The ground is passed through the unlock side bus bar of the right door lock switch to the unlock side bus bar of the left door lock switch. Then through the Z8 circuit to ground G203. If unlock is pressed, the circuit operates in a similar manner, except power and ground are reversed. Checking the circuit description on the previous page confirms this information. So now it's time to start looking for the problem. First, we check the fuses in the PDC and fuse block and find them both okay. So the next logical step would be to check and see if there is power getting to both of the switches using a test light. Once the door lock switch is removed from the trim panel, we disconnect the connector from the switch. Next, we need to decide where to connect our test light. Now, one lead should go to the power feed and the other lead to a ground cavity on the harness side of the connector. So if we look up connector C316 in the connector pinout section, we find that pin 5 is the power feed and pins 2 and 4 are grounds. We could have also gotten this information by looking at the switch on the wiring diagram. We see that pin 5 is the power feed, and pins 2 and 4 lead to the ground. So now that we know which pins to use, let's connect the test light. And we see that it illuminates. Now this indicates that the wiring between the battery and the switch is okay. Now, before we move over to the right side door lock switch, let's check the left door lock switch itself to see if it's damaged. Now, you can do this by checking the continuity of the switch in the off, lock, and unlock positions. By looking at the diagram in the service manual, we can see that in the off position, there should be continuity between pins 2 and 3 and between pins 1 and 4. If lock is pressed, we should see continuity between pins 1 and 5. And if unlock is pressed, between pins 3 and 5. If you need to review these pin numbers, see the chart in this month's reference book. So using an ohm meter, we check for continuity in all 4 positions and find the left side switch to be functioning properly. Next, let's move over to the right side switch and check it. Using the test light to check for voltage to the switch, we find that this is not the problem. But when trying the continuity test on the right side switch, we are immediately alerted to a possible problem. In the off position, there is continuity between pins 2 and 3, but not between pins 1 and 4. Moving the switch to the unlock position, we find continuity between pins 3 and 5. But checking the lock position, there is no continuity between pins 1 and 5. Now this would seem to indicate a break somewhere around this part of the switch. But does this make sense? That none of the doors will lock or unlock because of a problem with the right door lock switch? Well, if you think about it, we know from the wiring diagram that both the voltage and ground for all 4 door lock motors is provided through the right door lock switch. So, with a break at this point in the switch, both the lock and unlock functions would fail. So, if we replace the right door lock switch, the system should operate properly. And verifying our repair, we find that the system works just fine.
Well, I'm impressed.
Well, Mike, you were right. These diagrams are much simpler to use.
Well, I'm glad to hear it, Dennis. And since you did such a great job with the sample problem, why not finish up with a review question?
Sure. Now, during our sample problem, we were able to tell the right door lock switch was bad because A, the test light illuminated, B, there was no continuity between pins 1 and 5 in the lock position, or C, there was no continuity between pins 3 and 5 in the unlock position. Well, the answer is B. We were able to tell the right door lock switch was bad because there was no continuity between pins 1 and 5 in the lock position, or pins 1 and 4 in the off position, indicating a break around this part of the switch.
Well, I guess that brings us to the end of another Master Tech. And I'd like to thank Dennis for all of his help. Now, before we say goodbye for another month, there's a couple of things I should mention. First, the door lock circuit we just looked at in the sample problem is probably going to be changing with the next edition of the service manual, as are some of the other wiring diagrams. So be on the lookout for the new service manual and for TSBs with updated wiring information, since they may have an impact on vehicle diagnosis in the future. And if you have questions when using the new wiring diagrams, check your technician information update on simplified wiring diagrams. It reviews most of the information we've covered this month in a quick reference format. Finally, if you have any comments about the new wiring diagrams, we'd like to hear from you. So send in the comments form in the back of your service manual and let us know what you think. Well, once again, thanks for joining us. And we'll see you next month on Master Tech.